Hi, welcome. Are you having a good Ignite so far? All right, okay. So we have a lot of content to cover today, so hopefully that'll wake you up from your afternoon slumber, right? So stay tuned. So let me introduce myself. My name is Sudhakar Sinakela. My team and I are responsible for open source databases in Azure, and we're also responsible for database migrations to Azure. And today I'm joined by my colleague, Sunil. Sunil, raise your hand. He will talk a lot about, he'll show you the latest and greatest that we're building for the service. And we have Dave Buse from Adobe, one of our key customers. He's going to talk about how Adobe is using the platform. So today's agenda, I'm going to walk through our experiences building this fully managed open source database in Azure. And Sunil will do a deep dive on a few topics that DBAs and IT admins care about and have been asking us. And Dave from Adobe is going to talk about their experiences using Postgres on Azure. And we'll wrap it up by showing you how to migrate your databases, open source databases to Azure, and we'll have a Q&A towards the end. I also want to give a shout out to my team members who are present. Can you raise your hands? These guys will hang out after the talk. If you have further questions, they'd be happy to take them as well. Okay, let's get started. So our journey started about 18 months ago when customers who are traditional SQL Server customers and customers who bet on Azure wanted a solution for a fully managed open source database like Postgres, MySQL, and MariaDB. And when we started our journey, these were the questions that were commonly asked. Like, how do I manage my hardware purchasing and management? How do I protect my data? How do I make sure that my databases are highly available and support disaster recovery? And how do I secure my databases against malicious attacks? And how do I upgrade my database with the latest and greatest features, upgrade security patches, and so on and so forth? And finally, how do I troubleshoot my data and make sure that my queries are performing very well? So when we started our journey, our goal was to answer all these questions and provide a fully managed open source database in Azure that's a first-class service. So that's the journey that we began about 18 months ago. About 6 months ago, Postgres and MySQL were generally available, and this week we announced MariaDB in a public preview fashion. And the response from customer has been overwhelming. So as I said, currently we support two engines, MySQL and Postgres, that are generally available. MariaDB is in public preview. This service is available in 35+ regions worldwide, and it's growing. We serve customers across more than 100 countries worldwide. And we have about north of 26,000 paid customers that are using the service, and they are growing at a rapid rate of 12%. So we are actually the fastest growing service in history in Azure Data, and we're very excited about it, and thanks for the support. Okay, so when we started building the service, it was based on a few fundamental principles. The first one was around, we wanted to operate community editions of these open source databases because that's what our customers have been asking us for. The second reason for doing that is we wanted to take the great innovation that's happening in the community and give it back to our customers in a managed fashion on Azure. And the third reason is we wanted to support all the open source community tools, languages, and language frameworks seamlessly. So due to these three reasons, we wanted to make sure that lift and shift scenarios from customers operating their databases on-premise or a private cloud and seamlessly migrate them over to Azure. So that is the reason why we took a design decision that we will not deviate from a community edition of these open source databases. The next thing that design principle that we followed was based on customer feedback was to offer highly available and scalable databases on the cloud. Azure is the only public cloud that offers high availability, 99.99% availability across all pricing tiers, and this is a differentiator compared to other public clouds. The third area that we invested in heavily based on customer feedback was secure and compliant. Azure is the most compliant public cloud in the world, and we wanted to take advantage of that and provide the same level of industry-leading compliance certification to open source databases as well. And The next thing that we focused on is, given our customer surface area was spread across 100+ countries, we wanted to take advantage of Azure's global reach of 40+ regions and wanted to provide this service currently to 35+ regions, and it's growing every month. And finally, when developers and IT admins and DevOps and DBAs talked to us, they wanted to take a huge bet on Azure, and they wanted seamless integration with other Azure services for these open source databases. So we did a lot of work, and I'll talk a little bit about that later, how our service integrates with the rest of the Azure services to enable your scenario, whether you're a DBA or an IT admin or a developer or a DevOps person. And the same services, the capabilities that I just talked about Postgres and MySQL, are currently available in preview in MariaDB. Please sign up and check out the service. So today I wanted to touch on a couple of topics that are of interest to IT admins, DevOps, and DBAs. This is based on the journey that we went through in the last 18 months, and I will touch on starting with availability and performance, and I'll talk a little bit about security and compliance. The third area is around manageability, monitoring, and tuning, and finally, integration with the rest of the Azure ecosystem. So open source databases in Azure, we have built-in high availability of 99.99% in a single AZ configuration. And this is industry leading. No other public cloud provider provides this. And we do this at half the price of other public cloud providers. And I'll talk about that a little bit later. The second thing that we focused on is, this is based on customer feedback. The service provides automatically scaling of storage and compute based on your workloads. Because typically, our customers don't want to over-provision databases. They want to provision databases based on the workload, the standard workload that they're expecting. And they wanted us to provide an easy compute and storage scaling mechanism to accommodate for their peak workloads. So that is built into the system as well. The third thing is, we support disaster recovery scenario. Those are built in as well. We offer a few options for our customers, and I'll talk a little bit about that. That comes as part of the service. And finally, we offer a plethora of SKU options for customers depending on the workloads, so that you can build applications based on the needs of the size and shape of your data workloads. So let me talk a little bit about how we offer high availability. The way our system is designed is, we have an application connecting to a gateway in Azure, and the gateway connects up to what I call a database compute node, which in turn connects to Azure Storage, which is our persistent data for these databases. And we have an Azure Database Management Service that monitors and manages these database compute node. Right? So when a storage copy goes down, we spin up another copy of the data. So at any point of time, we have 3 copies of user data. Sometimes they're locally stored in an availability zone in a region, and sometimes it's geographically distributed as well, based on the customer's requirements. And if the compute node goes down, we spin up a new database. The way we operate this database is in a very lightweight, secure container that's custom built for this service. And this enables us to quickly spin up a database node in a few seconds, roughly around 30 seconds. So as long as the application has retry mechanism built in, our customers should not see any downtime. So essentially, if a storage copy goes down, or even the database node goes down, your application doesn't have to face any downtime. So as a result of this architecture, it also helps us provide elastic scaling based on the workloads. So as I said, the database runs in a secure container, and if our customers want additional compute capacity for your database node, you can quickly spin up a new compute node without having to take downtime, because the way we built the system is based on a container model, a custom container model, where we can quickly go spin up a new database compute node. Similarly, on the database, on the storage side, you can actually increase your database storage size and get higher IOPS if you're expecting more customer workloads. And this is an online operation. It doesn't require any application downtime. With a simple slider, changing a slider in the Azure portal, you'd be able to get extra storage and more IOPS for your application. And we'll show you a demo of that later in the presentation. Okay, so as a result of this architecture, right, in addition to giving high availability in a single AZ configuration and also provide you this elastic scaling of compute and storage, there is a TCO conversation at play here as well. For example, if you want to run these open source databases in Azure virtual machines and get high availability at the same time, you need to at least have two compute nodes for your database, right? So when you look at the price comparison, we offer high availability built in one single instance. But however, if you keep the elastic scaling part in mind, essentially you don't have to over provision your databases. You can provision your databases based on your normal workloads and use the elastic scaling capability that we provide to increase the size of your compute node or your storage to make sure that your application can function when you get more workload. So as a result of this, the customers end up paying half the price that they would normally pay if they're running these databases in either a virtual machine setting or in another public cloud provider. So this is a huge exciting thing for our customers, where they can get extremely high price performance and return over investment, but by paying half the price that they would normally do in a virtual machine or another public cloud setting. So a quick note on the different performance tiers we offer. We offer basic, general purpose, and memory optimized queues. So if your workload is light compute needs and with variable I/O performance, we have the basics queue with 1 or 2 vCores. And then we have the general purpose queue that is ideal for most business workloads when you have a good mix of compute and storage needs. And if you have an application that requires faster transaction processing and higher concurrency, we have the memory optimized version. Right? So as of today, we support MySQL version 5.6, 5.7, and 8.0 is coming soon. We plan to announce it before the end of the year. And we support Postgres 9.5, 9.6, and 10.0. And as of 2 days ago, we support 10.2 in MariaDB in a public preview fashion on the service. Okay, the next topic I want to talk about is security and compliance. So currently the service supports native Postgres, MySQL, and MariaDB authentication. We are working on Azure Active Directory integration as well. You can control access to the databases using a variety of firewall and VNet rules. You can secure your data using built-in encryption of data at rest and in motion. We use AES 256-bit encryption for the data that's at rest, and we support SSL TLS 1.2 for data that's in motion for you to connect to the database. The two things that I wanted to point out that are very, very unique for our service in Azure. One is what I call the Azure IP advantage. Right? Azure is the only public cloud that provides full indemnification to our users when you're running open source software in a public cloud. And we help protect our customers against IP infringement, patent loss, and also against any legal ramification. This is very unique for Azure. No other public cloud provides this. So what it means to our customers is you can safely run any open source software in Azure, including open source databases, with full protection from Microsoft. And the second thing which is unique for us is we have industry-leading compliance offerings. For example, if you are in the financial sector, we have PCI level 1 compliance. And if you're in the healthcare industry, we have HIPAA compliance. And we're constantly working on adding new compliance certifications worldwide. We're working on, for example, C5 compliance for Germany that's required for if you're a finance company in Germany, for example. But we are industry leading here, and the reason for doing this is because we have customers spanning worldwide in 100+ regions worldwide, countries worldwide, sorry. The third topic I want to talk about is manageability. We offer built-in backup and restore capability, and I'll talk a little bit about that. More recently, we worked on advanced monitoring and alerting capabilities for the service. This is based on the feedback that we got from our customers, where the traditional DBA tasks, they wanted us to be fully automated. So we worked on that, and you'll see a demo of that later today. The third thing, which I'm very excited about that we announced recently, was around intelligent performance tuning. One of the things customers asked us was, look, I don't want to, DBAs say that I don't want to go understand, what's happening with my performance. whether they're degrading on a day-to-day basis. Can you help us provide some automation around that? So we built some intelligent machine learning models to understand the shape and size of customer workloads and alert the customer if they're seeing any performance degradation. And not only that, we also offer recommendations to our customers on what are the steps they should be taking to make sure that the performance of their app is not degrading, and also how they can improve the performance of their application. And you'll see a demo of that later today as well. And finally, in manageability, we worked on AI-based security protection. So we have machine learning models running in our system that look at standard workload patterns, and whenever there are any anomalies or any inclination of any security attacks like denial of service attacks or SQL injection type attacks, we flag it to the customers. And also, not only that, we provide preventive actions that the customers can take so that their databases and data doesn't get compromised by any attack vectors. So for backup restore, as I said, we provide built-in backups. The customers can choose for the backups to be locally within an Azure region or geographically distributed. We guarantee an RPO of less than 1 hour in case an Azure region goes down and we have to invoke a disaster recovery step. And the backup storage cost is included as part of the service. And we provide support for point-in-time restore for anywhere from 7 to 35 days. So this helps, in your disaster recovery scenario, you can recover the data at any point of time between the 7 and 35-day time period. And this is configurable by the users. The next thing that we recently worked on was built-in monitoring. Currently, we support on Azure Portal integration with Azure Monitor, and we expose telemetry data, both operating system level telemetry data and also database-specific telemetry data and perf counters and things like that for our DBAs to go take action against if they see any anomalies. And in addition to that, we have a push model as well where DBAs can configure certain alerts based on certain criteria, whether, for example, if a CPU percentage on the database box goes above a certain percent, and we send email notifications to the DBAs, to the subscription owners. So this way, the DBAs don't have to go to the portal and check how their database is doing. We send these alerts whenever some anomalous activity is going on in your database. So the next thing, as I mentioned, that we worked on is intelligent performance tuning and recommendation. One of the things that we show the users is what are the longest running queries in your database. So we recently enabled this in the portal. You can log into the portal and look at how your application is performing and what are the top slow performing longest running queries. We also show wait statistics. We show about, hey, what are your queries really waiting on? And not only that, we also offer, based on the telemetry data that we collect, we offer recommendations to our customers on what they can do to ensure better performance for these databases. And you'll see a demo of this later today. And as we've done the similar work that we've done for performance tuning, we've done the same work for security as well, where we collect a lot of this data on the kind of connectivity and the kind of queries that your database is experiencing. And whenever we see any anomalies, we flag the user. And not only that, we give recommendations to our customers on what they can do to secure their database. The next topic is around Azure integration. This is something that we've got a lot of feedback from our customers, that irrespective of their persona, like for example, a DevOps person, they're used to using Azure functions, and they wanted tight integration with these open source databases, for example, with Azure functions, and we've enabled that. Similarly, we have integration with Azure Support Center and also Azure Monitor to make sure that the customers to satisfy their manageability and performance tuning needs. We also built in integration with Power BI for data visualization type scenarios, and also integrated with advanced analytics and AI with Azure Machine Learning. We have customers who are looking at the data and doing interesting things like anomaly detection and other interesting scenarios. So we've enabled that with tight integration with Azure Machine Learning services. And finally, we announced this earlier this week. We are providing first-class support for the Azure Database Migrations Service to enable online migrations of Postgres databases and also MySQL databases to Azure with minimal downtime. We announced that earlier this week. Okay, and in addition to that, as I mentioned, we're taking advantage of Azure's industry-leading, global reach, and as a result of the industry-leading global reach and also integration with other Azure services is unleashing very, very interesting scenarios, and customers are building interesting application and interesting workflow automation for DevOps, DBA, and IT admin type scenarios. So in summary, remember the list of questions that customer asked us. So we try to tackle each one of these questions in a systematic fashion. First is around hardware purchasing and management. Customers didn't want to take care of capacity management, and we built built-in scale on-demand thing that I talked about. And we also provide, as I said, high availability and disaster recovery that's built in to make sure that customers don't have to worry that their databases will ever go down. We also, as I mentioned, implemented advanced security features and are industry leading in terms of compliance requirements, so we take care of that for our customers. And we roll out updates and upgrades of new feature that the community is innovating, and including any security fixes that come in, any security vulnerabilities. We're able to patch our servers in a very quick fashion. We take care of that for our users as well. And we provide monitoring, troubleshooting, and management at scale, as I talked about, and you'll see a little bit of demos later on today. And that's automated as well. And we help customers tune and maintain to make sure that they get predictable performance for their applications. So essentially, we're very excited about what we built, and you'll see some demos later on today. Our goal was to make a fully managed first-class PaaS service for open source databases. And we feel that we've done that, and we're getting constant feedback from our customers, and we'll work on constantly improving the service. So with that, I'll invite Sunil to kind of deep dive on a few topics that we talked about: performance, manageability, and security. Thanks.
All right, so my name is Sunil, and I lead the product management for open source managed databases on Azure. So the three key topics that we listen all the time from our customers in terms of what they care about, especially from the DBA and IT administrator community, is how do I get the best performance? How do I deliver the TCO benefits to my business unit? And which is all around, revolving around performance. And second one is, how do I monitor and tune? Most of the DBAs and IT admins are typically playing ping pong games with the application developers about who is right and who is wrong. Is it the application fault? Is it the database fault? And how do we equip you as the DBAs or IT administrators and empower you to actually have the meaningful dialogue to impact the application performance? And lastly, security. Everything revolves around protecting your customer data. And how do you implement the necessary policies, controls, and strategies to make sure that your customer data is protected? So let me first start with everything about performance. So Sudhakar talked about the three performance tiers we have: basic, general purpose, and memory optimized, each providing unique benefits and fit for handling specific type of workloads. Basic, if you want to do dev test workloads, or you want to host very small applications which do not have a very key performance requirements, basic is a very good tier. We believe general purpose is the most optimal tier for most workloads, especially if you're running on production. It offers balanced compute and memory, and also fast storage performance using SSD disks. And then finally, memory optimized for those that really want to run I/O intensive, want to cache more data, or run more connections, run more concurrency on their applications. They can easily use memory optimized. So we already showed this chart to you, but now I want to focus on a few attributes. We offer compute in the form of Gen 4 and Gen 5. When we started rolling out our service, we had only Gen 4 compute. And then Azure continuously innovates and brings the latest generation of hardware to our customers, and we introduce Gen 5. And then when we introduce Gen 5 mostly offers you like 15 to 20% better performance per core compared to Gen 4. But we price it the same as Gen 4. So if you have Gen 5, as of at this moment, we have Gen 5 rolled out and available in all the 37 regions that we showed you before. So if you are running a workload, it's likely you'll have a better price performance if you run on Gen 5. And then the compute scaling. You can start 2, 4, 8, 16, 32, and then we are working on enabling 64 cores as well. And one of the attributes that you want to consider, how many cores do I need, is not just based on how much CPU you need. The other scaling vector of how many cores you need is also dependent on how much memory you need, and then how many concurrent connections does your application need. The number of connections scale with the number of cores and the amount of memory available per core. On that point, if your workload is not running very high CPU, you just want many connections, because I've seen many microservices-based architecture that tends to open a lot of connections to the database. But not all connections are active or idle, or mostly idle. In that case, having to go to a higher CPU core on general purpose is not the most optimal way to use your dollars. Instead, at just 35% more price, you can use memory optimized. And you can get double the connections compared to general purpose. So that's the consideration. So if you're running in a microservices-based architecture, or you have application that's opening a lot of connections, but not all are active, very likely you'll have a better price performance running on memory optimized tier. So let me now demo the elastic scale. All right, so here I have a very insert, update heavy workload. And as you can see, it's running currently. It's running about 0.6 transactions per second. Don't worry about the number. But and you also see the average latency here is pretty high. It's 17 seconds. This is currently running on a two-core general purpose with 5 GB of storage. Right? In our service, the IOPS scale with the storage at roughly 3 I/O per gigabyte. So the more I/O you need, you have to scale your storage up. Now, let me show you how seamlessly you can increase storage and therefore IOPS and improve the latency and the transaction throughput of your application. So for that, all I have to go is to the pricing tier on the blade, go all the way up, and just select OK. And now you can observe how the transactions per second is now instantaneously increasing and the latency is decreasing. You see the average milliseconds now? Your transactions per second is 1.3, and your average latency is cut by half. The application did not even notice. That's the value we are providing to our customers, that even during the scale operation, there is no impact to your workloads. You just get better performance. But most often, we also find that workloads just cannot scale up. They need ability to scale out as well, especially those workloads that need to run read-only, like BI workloads, analytical workloads, dashboard workloads onto the readable replica. So we announced, at Ignite, we announced public preview for readable replicas for MySQL. So with this, now you can set up to 5 replicas and then scale your workload out for your operational read-only workloads onto these replicas. We also offer in MySQL what we call the data in replication. Now, this data in replication allows you to scale out across Azure and also on premises. So think about a scenario. If you have your MySQL workload on premise, which is a master, and you want to set up a replica, you want to set up a read replica on Azure so that you can point your operational workloads, you can do that with data in replication. Or let's say you want to scale, you want to run a globally distributed application. You want to set up your replicas in multiple different Azure regions so that your applications can get localized latencies to the MySQL in those regions. You can do that with data in replication. Of course, we are going to eventually add these scenarios to features like read replica, but today we are also giving you options that you can use to customize and use it in a way that will give you more flexibility. All right, everything about performance. Now, how do I go and make you productive in terms of monitoring and tuning? Because this is one of the most key challenges. Now, we talked about the built-in metrics. The service already gives you 90 days of historical metrics at 1 minute granularity. You can customize it the way you want. And it's also now integrated with OMS log analytics that you can push these metrics for longer-term retention or run log analytics on it as well, so that you can get a holistic performance view, not only from a database-centric, but from the context of a database, application, load balancers, other tiers, network resources. In log analytics, you can pull all of this data together and then drive meaningful impacts. We also allow, out of the box, standard database engine monitoring, which is available with MySQL and Postgres. So with MySQL, you have information schema, performance schema, and sys schemas. So you can continue to use these views and schemas to pull the metrics necessary to do your performance analysis. And similarly, on Postgres, we enable PG stat statements and PG buffer cache that you can use out of the box. If you are used to running these tools, you can continue to do that. But what we heard constantly from our customers is that no matter how many metrics we expose, it's insufficient, because you as a DBA or an IT admin have your favorite parameter that you want to visualize. And we thought hard, what is the best scalable approach that we can empower you as a DBA and IT admin to do what you want to do? And today at Ignite, and this week, the monitoring team announced custom metrics. Now with this custom metrics, you can pull your favorite database metric, whatever that is, from the database, and visualize it together with our service metrics. And I say what I mean what I'm saying. Is any of your favorite metric, you can now visualize alongside with our service metric. So that means more data in your hands to actually drive performance optimizations. So now let me go give you a demo of what this custom metrics looks like. If my laptop doesn't sleep. So what I'm going to show you is how you can write a custom metric and visualize it on the Azure portal. Yeah, I think I lost count of the thing. So here is a very quick example of I've written an Azure function, and that Azure function is registered to my Postgres server that I have created, and I'm passing on the credentials. And then I am pulling the data. I'm pulling the metric that I like, which is one of the most important metric. If you are a Postgres user, you always want to know what is your longest running global transaction ID, because in Postgres, the transaction ID wraps around. So if it's beyond 2.1 billion, you are in deep trouble, because that's a 4-byte integer in Postgres. So that metric is currently not exposed on our service, but I want to know. But I know this is my most favorite and important metric. So with this, with the Azure function, now after creating this metric, where I have this select max age day dat frozen XID, and now let me show you. Go into the portal. I can now publish this function through Visual Studio Code, and go to the metrics pane on the portal. Select the metrics. So typically, the metrics that are exposed to you by the service, you select Azure Database for Postgres as the metric namespace. Now what I have done is now I've created a new namespace that has the custom metrics. And it's not one metric. In that same Azure functions, you can select 15 or 20 different metrics on that namespace and then project it out, publish that Azure function, and then select those metrics. I got it here visualized. And now I see it graphed on my metrics page. So in addition, together with all the other metrics, I can create different views of my metrics. I can say all my transaction-related metrics, all my log-related metrics, all my buffer pool-related metrics, all my connections and user application-related metrics. I can group those metrics the way I want it and then consume it to drive my performance optimization and also alerting and tuning on this. All right, the next most important thing that we got feedback on was, as you know, the service offers free, integrated logs where you can retain it anywhere from 1 to 7 days. And you basically download the logs. The idea there was we'll give you the standard MySQL, PostgreSQL, MariaDB experience in consuming the logs, and then you can push the logs through your favorite open source tools and do your analysis. That was our first phase of what we thought that we wanted to do. The next phase at Ignite, what we announced this week, is now these logs are integrated with Azure Monitor for diagnostic logs. And that now empowers the IT administrators, like you, that can take these logs and either store it into a storage blob account. And like the scenario would be that if you want to persist these logs for a period of 1 year for compliance reasons, you can do that and archive it to a cheap blob storage. Or let's say you want to go drive analytics on these logs. So you want to consume MySQL slow query logs or Postgres server logs, and you want to mesh it, or you want to combine that with other application metrics and logs so you can run some analytics on it. You can do that as well. And you can also send it to event hubs. So all of these powerful capabilities are now enabled via our integration with server logs. And also the Azure Monitor server logs are integrated with any third-party tools as well. For example, if you are in your enterprise, have standardized on Splunk, the Azure Monitor is already integrated with Splunk. So you can take the same logs and push it to the third-party tool as well. So it gives you the widest choices, regardless of which tools you are either using today, or if you don't have a preference of a tool, we give you all the services and capabilities that you can drive analytics and do your troubleshooting tasks. And you can also visualize these logs and through Power BI as well. Now, this is my favorite topic. So again, coming back to performance. And I put it under tuning and performance monitoring and tuning. How many times have you had trouble understanding what is really going on behind the performance challenges on your applications? And how many times have you come across a situation that the application developer has said, your database sucks? You either don't know to tune it, or you don't, or this database is bad. We got to do some changes. And it's always the database fault, right? But the problem has been that like Postgres, for example, as a database, it provides very rich monitoring capabilities, but it has challenges. Because the critical challenge is it gives you metrics and views at the time of where the problem is happening. But how do you know at the time the problem happened? Because your application developer might say, or your business user will tell the application team that the performance, I had a lot of complaints from my users last week that the performance degraded by 10x. What happened? The application developer said nothing happened. And then says, database is your guy, it's your problem. Perhaps you have not tuned your database properly. And then you go on to the ping pong game or match between the application developer and the DBA. And let me tell you, performance optimization typically is being perceived as an art. It's not a science because it's hard. You have to correlate all data. You have to, first of all, know which data to correlate, etc. That is what we have made it easy by announcing intelligent performance, now available on Azure Postgres Service in preview. What this gives you is an ability where we store historical information about performance counters in our own database arranged in time series. That means you can go back to 30 days and figure out what happened and investigate performance bottlenecks, or what happened that caused the application to perform poorly. We are using the same standard Postgres views, for example. We have not built new monitors. We have not built new counters. But what we have done is we have assembled all of these metrics together and put it in a query store that is persisted in the same server that you provision for your database. It shares the same storage that you have provisioned for your database for. And you can retain it up to 30 days. And then you can run your favorite PSQL commands against Azure Sys, which is the default database that is now created where we store the query store. And you can run good analytical queries. So let me go and show you a demo. 7. All right. Yep. So I have a Postgres database, and Sunil PG10 server is my Postgres server name. I'm connecting it through my PG admin tool. And here I have this query store QS view. And I just want to show you how the schema looks like. I knew this was going to happen. Let me disconnect the server. Connect the server back. What I want to do is I want to show you the query store view. So now that the database is connected, you will see all the different columns that are now available for you to query on, right? So you have the query ID, the query text. You have the mean time, execution time, the max time, the min time, number of rows it touched, number of block hits, number of physical reads, blocks dirtied, and so on. Now, with this, I can now run a query where, in this example, I have written basically a query to know which of my tables have poor hit ratio, so that I can now investigate if my buffer pool hit ratio on a particular table or a set of tables is not optimal, then maybe I need to go and scale and add more memory. So that means go to either memory optimized tier or scale the tier. So I can take corrective actions, right? Or if I see that the read time on the physical I/O is going slow, I know I can now find out that the storage performance may be perhaps not adequate to meet my database workload needs. So I might want to go scale up the storage. So now I have this data. And now I can also go back in time, right? Like you saw the start time and the end time. Now I can go back 30 days and say, if someone were to come and say that, OK, 2 weeks ago there was a performance problem between 6 o'clock and 7 o'clock. All right, I have my data with me. And I can run any queries that I want in order to determine what happened during that time. Also available is now in the portal, as we announced, is Query Performance Insights and Performance Recommendations. Query Performance Insights gives you a contextual visualization of how much time is happening and who is consuming that time. Which queries are your top queries? What is the total execution time for those queries? So now I have a better view of what are the things that are happening on my database so that I can know, OK, these are the queries that I need to think about optimizing or look for opportunities on how I can optimize it. And then you have this weight statistics. And these weight statistics are nothing that we have created our own weight events. These are Postgres weight events, right? Now available in rich visualization that you can quickly figure out where is the problem. So here I have my top weight events. I go select on this, It says that it's something related to buffer I/O. That means perhaps either my buffer pull hit ratio is low, or maybe am I missing an index? I don't know, right? So then you go to performance recommendations, and in the click of a button, you can run analyze step to determine what potential opportunities are there for you to potentially optimize. So you run analyze, it runs about for a couple of minutes, and then it comes up with an index recommendation. In this particular case, it says, okay, very likely you will benefit from creating this index, which you can then copy, paste it into the PG admin, or run your PSQL, and create an index, and then see your performance improve. It also gives you what the estimated index size is. Because, and all the brain work behind, if I create this index, what will potentially happen to the inserts? Because there's no free lunch, right? You keep creating indexes to optimize your read queries, but there is an impact on the write performance as well, as you're inserting or maybe perhaps updating updating the tables. It has done all that analysis in the background, learning your profiles, and then come up with an effective recommendation saying, okay, after considering all my landscape in terms of what's happened to the workload overall, creating this index is the best possible thing that I can do to improve your workload. And it's as simple as that. So hopefully, so now with this intelligent performance, now you are more empowered to go drive the necessary conversations with your application development team and work collaboratively in order to improve your application performance, and therefore your end user experience as well. All right. So my last topic of the key pain point that you have, and the key worry that always keeps you up at night, security. Right? And you're never done with security. So let me start by expressing, I mean, this is from the latest Verizon breach report. You see that there are attacks all over the place. The attack vectors are just increasing. They could be from internally within your own organizations. They could be external forces as well. And there is no way for you to create your policies and implement your security strategy like with all the different things that could happen, right? So you have to have a very powerful defense mechanism and security guidelines, policies, and technologies that you can use from what is available, so you're maximizing the chances of securing your data. When we talk about, for the Azure Database Services, the security starts right from the edge. That's the internet connecting to a service in Azure. So from that perspective, it first passes through an Azure Edge network protection. Many people don't realize this. 2 services within Azure run as untrusted. Just because they're running in Azure, just because Microsoft built it, doesn't mean that we are trusting another service. That's number one. And there's already powerful threat intrusion detections happening on the edge to make sure malicious attacks, denial of service attacks are detected and corrected while it happens. Then, when the connection comes through that, it hits our gateway. This is our gateway. This is our Azure Database Services gateway. That gateway acts as a connection proxy. So when someone from the internet, or even someone from a virtual machine running on Azure, is running a ping on the DNS name of the database, many people think that it is connected, it's pinging directly to the database and the ACK is coming from the database. In fact, no. It's hitting the gateway and the response is coming from the gateway. The database is much further behind. And then once it goes through the gateway, it has through the SSL and has passed through the gateway, then we leverage the native database engine authentication to complete that connection. And that's when the ACK from the connection goes back. Now it's hit the database with the username and password. Now also, like, we give you different access controls to provide additional security. And what do we mean by that? First, SSL TLS 1.2 is followed end to end. It's enforced, number one. And then the first time you create the server, MySQL or Postgres or MariaDB, it's in lockdown mode. No one can connect to that database. So the first thing that you have to do is open up a firewall rule. What is a firewall rule? The client IPs that can legitimately talk to the database. Then you configure those client IPs, and then you have ability to connect to the database. Then we have data encryption and logging. On our service, data is encrypted by default. There's no switch for you to disable it. And on the wire, we have SSL. Then any operations that you're doing, changing the properties of the database, for example, you added a new client IP firewall rule, or you deleted a firewall rule, they are all logged in activity logs. You can consume these activity logs, and by default, it is integrated with the Azure Monitor for Diagnostic Logs. So you can use that to run analytics and say who is accessing us, who's changing the security posture of your instance. And the best practice is you want to consume these activity logs to make sure that you know what change events are happening on the server, who is adding the new IPs, who is deleting the IPs. And then we have this VNet service endpoints, where you can securely connect to the database from within a from within an existing VNet. And this allows you to provide private access only to the database. So only those VMs in the VNet can actually talk to the database. And this is now been generally available for the last couple of months. So with that, you have completed the data security lifecycle. But have we? Because the first best practice is discovery, where you establish the baseline, the security baseline. Make sure you know which data needs to be protected, and then you implement the protection mechanisms like data encryption, access controls. But is that enough? The most important challenge is detection. These malicious attacks that could be happening, how do you detect that as while it's happening? And that's why we announced availability of advanced threat protection, which allows you to detect brute force attacks, someone accessing your database with a login ID but is trying to change passwords constantly. Okay, maybe that is an attack. Or someone is trying to come with the same IP but has a different login and password. Or someone suddenly is trying to access your database from a region that never existed before. You can now safeguard yourselves and empower yourselves to understand and detect and also get remedial actions as and when this is happening. How do you do that? You just turn it on. And that's it. You just turn it on, and now you can go to the Security Center, Azure Security Center, and then look at all the log events so that you can know what's happening and where it's happening. So in the interest of time, I'm actually going to go faster, and also going to invite Dave Buse from Adobe on stage, where we have been partnering with Adobe for over 18 months and been a very good customer of ours. And what we asked Dave to do today was to share his experiences in his journey embracing Azure Database for Postgres.
Thank you, Sunil. Appreciate it. Are you guys struggling to keep up with the pace of things that are kind of coming at you, right? Anybody else kind of feeling that overload from announcement after announcement after announcement? To be honest with you, I kind of got overloaded just from the announcement of the keynote, right? So it feels like each Ignite in the scenario of Microsoft and Adobe's relationship is a new announcement. 2 years ago was the announcement around us partnering together to provide a lot better digital experiences for our customers. And that came with a lot of work on the Adobe side and the Microsoft side together to get the Adobe solutions onto Azure. And a lot of those Adobe solutions are using Azure Postgres for MySQL and Azure MySQL and Azure PostgreSQL. And really, we started that effort, Prabhat, Sunil, a few of us, we started that effort together 18 months ago. And most of the solutions that we needed, they're just kind of plug and play. They've worked great. The solutions that are there in place, plugged them in, really haven't had much conversation. They just met the need, and we went with it. There's a couple of scenarios where or use cases of our solutions that we knew were going to be challenging. They were challenging in other public clouds and on-prem. We knew they were going to be challenging here as well. And so we started partnering together early on. One of those, I mentioned in an earlier session, so some of you may have heard this a little bit before. One of those is Adobe Campaign. So Adobe Campaign is a solution whereby you can use it to create or define and visually orchestrate and then execute campaigns. So if you want to reach out, I'll use an example again of if you were a fast food vendor, and let's say you were in New York City, and you wanted to hit all the retirees, right? So you had a way to identify who was retired or in that kind of demographic by age. You can go out and you can say, all right, all the retirees, I want them to come in for breakfast, right? Free coffee for everybody that comes in for breakfast in that demographic. Now, that message they want to get out on time. They want to get it out right as people are getting up. They get that notice and they go, oh, hey, you know what? Free coffee today. I want to stop by this place, this particular vendor, and get a free coffee with my breakfast today. And then that gets tracked. There's lots of metrics that go along with that, and this is all done in real time. So you can go in and you can create your campaign, define who you want to target. You can define what message you want to get sent to them, and then you can execute that in the time frame that you want that to execute, and you can actually track and watch it real time, all right, of how that's being executed. So you can be a lot more engaged in what's going on, and it's all automated for you. The challenge with that is the combination of really, from a database standpoint, is I've got a lot of OLTP and a lot of OLAP. So I'm doing a lot of really fairly intensive queries for analytics, and at the same time, I'm handling all those events. I can have millions of events coming in a very short period of time, so I've got a lot of transactions that I'm trying to handle at the same time. And it's this combination of things that is part of what makes Campaign a challenging solution from a database standpoint. We also need to be able to scale up over time. So our customers are always growing, always wanting to have larger campaigns and be able to do those in shorter periods of time. And we need to be able to provide for them just, hey, good customer experience starts with availability. If it's not there, that's just a bad customer experience, period, right? And then when you think about it, this is a single tenant solution. It's a managed service that we provide for each of these customers. How many DBAs do you think we have for like 100 customers? Not a lot, right? We need to keep that fairly small in terms of the number of DBAs that are supporting the number of customers that we have. And so I could have 100, 200 more databases that I'm trying to manage. So it's got to be easily managed solution for us as well across a number of customers. And then from a security standpoint, we've got customer data here. It's got to be taken care of from a privacy standpoint. We also need to meet compliance requirements. So we need to have network access level controls. We need to be able to have, we have a minimum requirement of 1.2 for TLS for all in-transit communications. And everything's got to be encrypted at rest as well along the way. We have to have SOC 2 certifications, compliance certifications, both SOC 2 as well as ISO 27001. Those are just minimum bars for us. Got to have that in place. It's an interesting thing, though, from the kind of solution that Campaign is. You look at that and you say, oh, 24-hour RPO, that actually helps us a lot, to be honest with you. From an RPO standpoint, the kind of data that it is, that's fine for customers. They'd rather have a higher RPO at a lower price point than a lower RPO at a much higher price point. That's just the dynamics of this particular solution and the value that it provides. But they do need an 8-hour RTO built in. So that data's got to be in a separate region, right, to meet these. That's just one of the requirements. I got to physically copy their data so I don't have any risk of data loss within a given region. Okay, so you ask, why Postgres then? Really, that was a decision we made. It was made even before Adobe acquired the founding company called Neolane back in 2013. And they chose, I went back and actually talked to the architect that made some of those choices then. And he said, you know, the reality is a lot of why we made it then still applies today. It was this combination of OLAP and OLTP. Postgres does a really good job of that. It's one of the better databases for that combination. It was part of open source, so lower TCO. It had an active community to support it. And it also was very stable across minor version updates. So these are some of the reasons why it was just really important. And then ease of maintenance. Things like auto vacuum and some of those kind of features became very important to them. So that's kind of why Postgres, but why Azure Postgres? Why not roll it ourselves, right? The simple answer is we only have a few DBAs, right? We wanted a managed service, and that was just, there was a bar set, and we're just not going to be rolling this ourselves. So at the time the announcement was made, that was 2 years ago. You noticed it was mentioned 18 months ago, so when you kind of started this. So when did we start working together? 18 months ago. Right? We weren't very far into this when Adobe and Microsoft started working together. And so there's a lot of the things that are in the product today that come from that partnership and the work that we've been doing together and a lot of those performance recommendations. They've been fantastic in that engagement, and we've spent a lot of time together to get to a point where our solutions can be running in Azure, meeting our requirements for our customer use cases, for campaign in particular. Okay. So from a management standpoint, it's got to be easy to scale up, right? Both the compute and the storage, and as was mentioned, hey, 1 minute, click, done. That's beautiful. We need to be able to handle, or not have to worry about anything at the infrastructure level. No infrastructure as a service, no, all those things that Sudhakar had on his slide about the reasons why, it's the same reasons. That's why we went with a managed service, and it had to be, we have a 3 nines SLA, so we needed a database that was at least 3 nines 5, and they come with 4 nines, so that met our requirements. And it needed to be in all the places we needed to deliver for our customers. We're a global company with global customers, and we are constantly pushing the, hey, is everything that we need in this region, in this region, in that region? And so there's a lot of value in just having that there and ready for us. From a security and compliance standpoint, also, the managed backup, it just comes with it. Very simple, very easy. That part's just been nice to inherit that value and not have to worry about it, along with encryption and those certifications, as I mentioned. But what do we miss? With every choice that you make, every architectural decision you make, you've got some trade-offs, right? So some of the trade-offs that just want to be really transparent, right? I'm not here for sales. I'm here for just sharing experience. I hope to see some of you guys maybe up here next year sharing your experience so I can consume that from you. So some of those trade-offs are, hey, when you're not at the infrastructure as a service level, you trade off. You don't get things like queue depth. You may not get storage latency, some of those kinds of things, right? That's some of the just trade-offs that, hey, you take care of it, and let's just make sure it meets my needs, right? That's a trade-off. Other is there's some latency between what's available in the Postgres community and what is available on Azure PostgreSQL. But as you can see by all the things they're delivering, they're doing a great job of, as quickly as they can, kind of keeping up with those kinds of things as they come out. But that's one of the things that we recognize going into it. There's going to be a little bit of a trade-off there. And then lastly, is some of the limited observability on some of the performance tuning, like I mentioned. I mentioned the performance tuning. The other is some of the server parameters. There's some cases where you might have more server parameters you like to tune, and they're constantly adding more and more server parameters. A minimum one we had to have, for example, was workmem. Wasn't there. We had really good discussions, debates, because if you don't do workmem right, you shoot yourself in the foot, right? So Campaign is a really interesting one where it's fewer connections, but those connections do a lot of work, and they can use up a lot of memory. So we go with a higher work mem. We're sitting at 1 gig or even up to 4 gigs sometimes when we have specific things that we execute, as opposed to the default, which is like 4 meg, something like that. Okay, so how do we take, from a performance management security standpoint, integrate that in with the overall Adobe ecosystem, okay? So from a kind of a scale and performance standpoint, we're significant consumers of the metrics that come out. We monitor those metrics, alert off of those metrics, so that those admins, so we've got just a few of them for a large scale, they have to be able to consume those metrics. And then from a management standpoint, everything for us, going in, when it comes to campaign on Azure, it was a requirement, one-click provisioning. So what does that mean? When we're creating a new environment for a customer, we go to one place, we click the button, specify the profile for this environment, depending on the size of the customer and what they're purchasing, what we call package size. And it has to go and provision all the VMs, all the security, all the VNet service endpoints. It provisions the database. It takes care of everything except for loading up, handing that off to the customer and loading up the data. And one of the advantages that you have with something like Azure Postgres is that I've got an API for all those things, right? And then if I want to scale up, again, I got an API for that. So that was an important item for us to be able to just take advantage of that API that's part of ARM, so we can do that. We also consume the maintenance and alerts. So today there's about once a month or so, there's a maintenance update. Security updates, if those happen, they may fall in between. But you've got something somewhere along those lines, and so we have to consume those alerts that come. So we go into the subscription that we're running Postgres for campaign. We make sure we register for those maintenance events so that we can receive those and manage that as those occur. Today, those are typically a 30-second to 1-minute maintenance event. If you can take your application and it can handle, with connection retries, a 1-minute, 30-second to 1-minute event, that makes your life so much easier if you can do that. Highly recommend that if that's possible for you. And then lastly, from a security standpoint, we actually go and we consume the activity logs. We want to know who did what when, and we've got to be able to assert that from a compliance standpoint. We also interrogate the ARM API, and we look to make sure, okay, is this TLS 1.2 is a minimum, for example. And then we also consume the server logs. Okay, who logged in when, right? So we combine those together. We ingest those into a data repository and do all of our analytics and alerting from a security standpoint off of that. VNet service endpoints, as I mentioned, that's just a minimum bar for us. From a security standpoint, for customer data, we've got to have that for network level access control. And then we execute DRs. So we've got point-in-time recoveries that we can do. And we go through and we test those and validate that we can, because in this case, we're making copies to another region, right? That's part of what it does. And then we're recovering back to the original region, right, if we need to, so that we validate in a scenario of, let's say, for example, we had a region outage, but we want to bring a customer back to that outage as the region comes back up. These are really, really worst-case scenarios. So there's simpler scenarios and more common scenarios. I'm just describing the worst-case scenario, so because the simple common ones are obvious, you can do those easily. But we needed that 8-hour RTO, so we needed to make sure we can do that point-in-time recovery from another region and restore it within that 8 hours. And so those are some of the things. I hope that's valuable. Again, I hope to hear more from some of you guys maybe next year and what your experiences are. But that partnership has been extremely valuable, and we're happy to get where we are, and we're looking forward to a lot more. Microsoft's one of the key customers for their own partnership, and they want to scale way higher than we are right now. And it's fun to have marketing guys saying, hey, we need this, and being able to go back to the database guys and saying, hey, your buddies on the other side of the company need this as well. And it puts us in a fun position. So thank you.
The next section that we're going to go quickly is cover the topic of migration. So you all may have like databases that might be residing in your on-premises, and you want to have a very nice, easy way to migrate your data bring it to the Azure managed MySQL or Postgres. And also what we have heard is that customers really care for minimal downtime. That means they can take an outage that's hours or days. They want to happen it instantaneously. So at Ignite, we announced the public preview for migrating Postgres databases to Azure Managed Database for Postgres. We have been in public preview for MySQL for over a month. So if you have not yet if you're not yet tried out, please do try it out. Give us your feedback. We really want to make sure that the migration is seamless and it's designed and built to actually help you bring data onto the service. So with that, Naveen here is going to give you a quick demo of what does it really mean by online migrating your MySQL database to the Azure database for MySQL.
Hi, everybody. So for this demo, consider that I have this movie rental app, which is reading and writing to a MySQL on-prem database. Currently, it's hosted on Azure VM. So this is my IaaS on-prem setup. So what we have is online migration. So there is a migration running in the background right now, but my application can continue to read and write from the on-prem database. So let's say there's a new movie that's come in, and I want to add it to my database here. So let me go ahead and do that. So now this entry will go to my on-prem database. Okay, so as you can see here, so this entry is going to the on-prem database. Now let me switch to the Azure portal. So this is my DMS activity here, right? So there's a lot of information on the screen, but I'll quickly walk you through some details. At the top section, you have all the essential information, like what source server, what target server, what type of activity. And within each activity, you can choose to migrate one or more databases in parallel, right? So you can migrate like all databases on your server in one go. And now you can also drill into your database, and will give you more details, like table level detail, like how many tables are being migrated, how many rows per table. And so on the right side, you can see that we also show how many changes have been applied. So since I added a new row, this count will go up. And also there was some more changes that have come in right before this demo. And while we wait for those changes, I'll just quickly go over these two tabs down here, full load and incremental data sync. So these are two phases of the online migration, right? So first phase is when you start the migration, we'll do a bulk copy of all the data until that point. And while the bulk copy is underway, we will cache all your incoming changes, right? And apply and migrate them once the bulk copy is done. From that point on, what we do is we keep your source and target in sync, meaning like we continuously migrate the changes as they come into your source. So you can see we also give you more details of like different type of transactions that happened and the ones we applied. So let's say you have been running this migration pipeline for days or weeks, and you have finished all your testing and validation against Azure MySQL target, and you're ready to switch over, right? So at this point, you can put your source database into read-only mode, and then come to your DMS portal and start the cutover process. And you go through some instructions and start. So what is happening right now is we are migrating any remaining changes on source. And once that's done, we'll stop the pipeline right here. Once that's done, you can go back to your application and switch your application to point to MySQL target. So now I can see that all this data is coming from Azure MySQL Target. It has all the rows, including the last one, which I just added while the migration was running. So that's the beauty of online migrations. You have very little downtime. So yeah, in a nutshell, that's DMS.
Fantastic. Thank you, Naveen. That was, and the same, like as we demonstrated MySQL, the same is available for Postgres as well. So that concludes the presentation. I want to send you some links on the snackable videos that gives you like a step-by-step instructions on how you can go about using the service in the context of other Azure services as well. We also have several supporting resources that you can use, and email IDs that you can ask us questions, give us feedback. And in summary, what we have built is now the intelligent cloud database with scale and performance. So you got a taste of what we are we have already delivered this week at Ignite, and many more to come in the future as well. So this Azure database for MySQL and Postgres, and also MariaDB, is a self-learning database service that is extracting knowledge from running millions of databases and helping to bring that intelligence to bear in operating and making your job as a DBA or the IT administrator simple. So with that, thank you very much. We'll open it up for questions. We value your feedback, so please do submit your feedback form. Thank you.
Any questions?
Any questions that we can answer?
We'll hang out outside. If you have questions,
Yeah.
feel free to reach out to
Yeah,
us.
thank you for
Thank you.
coming here. Thanks.
Thanks.